Okay, I think I'm back. Maybe. Let me know if you guys are getting the stream again. CenturyLink is really pissing me off. Problems detected at CenturyLink. Oh, what a surprise. Since 4 a.m. Eastern. I don't know what their issue is, really. They were so stable, and then all of a sudden they're having issues. Very annoying. Yeah, we Americans are... Yeah, give me 1 sec. Okay. Okay. Fun stuff. So Journey started, asked about status, progress update. Nobody's actually asked me that today, so I mean, I would say we're in pretty good shape. I mean, you know, my to-do list isn't that horribly large, and, you know, I'm making good progress. And of course, some of the things in here are more important than others. But I do, as I fix things, change things, I uncover new stuff, so the list is not, you know, strictly fixed. I'm in the process of extending the compiler to support procedure overloads. I don't, other than the refactoring I'm doing now, I don't really anticipate too much complication with it. So, yeah, I mean, the big things are the family expressions for the constraint system, reworking the constraint system a little bit to take into account, you know, families, multiple name return parameters for procedures. I don't expect this to be, like, I think everything I need is there. It's just mostly restructuring the code gen and the compiler to do the right things. You know, clean up for errors. Actually, this is done. There are still some things around stack frames that I need to deal with. Array subscripts, I'm kind of punting on this until towards the very end because I'm still thinking about exactly how I want to do that and at what level I want to do it. There are some issues with multiple assignment. It's code gen issues. It doesn't put things in temp registers when it should. You know, the procedure call evaluator in the AST evaluator is kind of a rat's nest right now. I need to refactor that. There are several small type checking issues. These are all just type check stuff. So essentially the register allocator, I think ultimately what I want to do there is I had this really great light bulb go off when I did the inline assembly, because so right now the iLocal, flocal directives, they only work within the inline assembler. They're actual directives, they just don't ever propagate to the assembler proper. And it occurred to me yesterday that I could really make dealing with the basic block liveness detection if I propagate this behavior all the way back into the actual assembler. Like, these would be real directives, but in order for that to work, I need to refactor how instruction block works and how I need to do another kind of like global refactoring, although it shouldn't be too bad. this time, but it will impact all of the code gen. And the long and short of it is, right now, again, like I've been backing out all these stack things that I did. Like the assembler has a block stack, and the code emit is interacting with that stack, and that's not really ideal. So, you know, what I want to do is refactor, so we have the emit result T. I want to put an instruction block pointer on here, okay. And we do that now. And essentially, you call emit. The emit is going to ask the assembler to allocate a block. He's going to put the pointer here, and that block gets returned to whoever called emit, and then they can decide then to add it into the block sequence, you know, in the assembler, or cache it and insert it later, or whatever, right? So it gives the caller the control over when blocks are sequenced. But in addition to that, then we're going to be creating more blocks. So right now, the assembler or the code generator really doesn't create that many instruction blocks, but that's going to change. We're going to create many more blocks, and they're going to get closer to like a basic block type structure. And then because of that, what I can do is we can put that local register allocator behavior with the iLocal, flocal directives into the instruction block. So the scoping of those local variables in that instruction block are managed by the block. So then in instruction block, when we say you know, assemble, which I think is actually, it's an assembler. Yeah. Right, so here we're walking all the blocks, we're walking all the entries in the block. So essentially what will happen is I'm going to put a new interface on instruction block where we activate it, right, prior to doing the assembly, and then at the end we deactivate it. So it goes into scope, any locals that need to be allocated get allocated, and then at the end we free it. So that's going to end up being a much cleaner, much cleaner approach and more flexible. And then what ends up happening in CodeGen is now, you know, all the CodeGen is all focused on registers. But that will go away because now I'll be able to refer to these local variables essentially, and I'll have a you know, an instruction operand. We'll extend an instruction operand so that we have a local ref, right? And so we'll have a local ref, we'll have a module ref or a heap ref, and then a label ref. And the encoding, you know, I'll have to adjust it a little bit. And then in the assembler, we'll have some extra structures that keep things straight. But this mechanism then can propagate throughout the entire code generation process. And then, excuse me, that allows us to have locality of variable access to the block that it's applicable to, but the duration will be longer than what I had before. The liveness will be better. the one I had before. Then the other thing too, like in procedures, so the parameters and the return value and any locals, those are all in the stack. And right now the code generator is constantly generating loads and stores with offsets from the frame pointer, which kind of sucks. So instead of that, once I have this local mechanism kind of plumbed into the entire assembler, what I'll be able to do is for anything that's accessed, right, I'll create a local for it, and then we'll have the cogen will emit a single move instruction which does the offset once and applies it to that local variable, and then that's our addressing variable for that, or that addressing register for that variable within the scope of that, or well, that scope, period, whether it's a procedure or not. And then of course I can set some heuristic, right? So I have 64 integer registers in the interpreter in the bytecode. So, you know, I can say, hey, if we allocate, you know, more than 32, just say half of our integer registers to locals, then start spilling back to the stack. So then in that case, let's say you had some crazy scope, it had 100 variables in it, you know, it would create locals for everything that it can. For the ones that can't, those just become the load and store from the stack offset, like they always were. So anyway, that's a big thing. I think that'll, and change-wise, I don't think it's going to be horrible to do. Like getting the structure in place, you know, refactoring it to that model should be relatively straightforward. Then it'll be the process of optimizing the code generation again to take advantage of that approach. And then, yeah, you know, I've got questions about, in my mind, how I want to finish off the type system. I think I've talked about this before, but like string type, any type, dynamic array types, a lot of that stuff, right now it's written in C++. There's really no compelling reason it needs to be anymore. I mean, Basecode's getting better and better by the day. Like I already have the equivalent, right? This code is the equivalent of this, right? And this is, you know, 69 lines long. This is 5 lines long. And I mean, in terms of bytecode, right? Because they both generate bytecode. This code here, this is all, this is generating bytecode. It's not like it's generating native code and that's different or special. They do the same thing, right? So this actually ends up being nicer. No, yeah, see, no, it doesn't matter, right? Because they're both generating bytecode. It doesn't, in this particular case, the purpose of that C++ code is to generate bytecode. And the reason I put it in C++ is because I couldn't do this yet. But I can do this now, right? So it's things like this where I originally had to put it in C++, and it, you know, there's really no reason for it to be there anymore. So there's probably a round of refactoring for some of that and hoisting some of those types out of the compiler. The only thing that really needs to be in the compiler are primitive types, honestly, which we've got all those, right? So pointers, numbers, booleans, you know, maybe arrays are weird. I'm still batting around what I want to do with arrays. So the compiler won't support anything at a primitive level. If you want to type wider than 64 bits, you can create one yourself. I mean, that's, again, the ultimate goal with this is that if you want a 128-bit integer or 256-bit integer, you can write the metacode to generate the type, and it should behave just like any other type. You'd be able to use all the binary and unary operators on it. You'd be able to cast it. I mean, that's the goal, right? So I don't, again, the Basecode compiler should bake in the absolute minimum necessary. After that, you can, extend it however you need to. Hey, Tim Bade. All right, so the next step on this is, it's going well. Hey, Soding. Sorry. Wrong key sequence. Yeah, sorry about that. Hey, nerd it. Okay, I think I got everything. And again, my goal here, first step, is just to keep everything behaving the same way, even though the interface changed. Am I muted? Oh. I was going to say, sometimes OBS does drop my audio configuration, but it looks like it's picking me up right now, so. Yeah, I don't know if it's OS 10 when I upgraded to Mojave, or I don't know if it's the hardware or a combination of the two, but OBS was pretty stable in High Sierra, but okay. Let's go to procedure call, and I'm just going to assume that it's going to work. If it does, we get to this point, vars should be a list with 3 pointers in it in this scenario, because we've overloaded that procedure 3 times, well, twice, or there's 3 instances of it. All right, we got here. Oh, this is probably for print. Next power 2, print, exit, print. Foo. 3. Yay, look at that. So now we get the 3 identifiers that point at those procedure types, and awesome. So then the next step is we need to refactor procedure call. Instead of taking a single identifier reference, we need to create an array of identifier references for those identifiers. And then, yeah. All right, that's kind of positive. Okay. Let's run our test, make sure nothing blows up. Ah, Scheiße. Of course it couldn't be perfectly. Unable to resolve label. Why? Four, three, four, three, three. Huh? Weird. This is not being used anywhere. Traps 2628. Ah, interesting. Okay. I wonder. Because that one that failed, it was at least the constant lookup. That was a namespace lookup. Yeah, see, it's a list here. Why is it a list? it's always a list. Duh. Had to mess something up. Hey, Fletcher Codes. Hey, Can 988. Doing well. Hey, Born to be Reborn. Oh, lots of new stuff. I would say the language is getting closer and closer to done for the bootstrap, which is good. At the moment, I am working on procedural overloads, which kind of prompted a semi-reasonably large refactoring. Yeah, okay. Yay. paid a small performance price on that. Okay, so let's review that, because that was pretty big. Okay, so I moved some type defs out of the scope manager header into the element types header, because that's where we have type defs, type aliases, whatever you want to call them, for everything else. So inside the scope manager, there's several functions that are visitor functions. There's a couple variations of visiting scope blocks, going from a current block and up, or going from a current block and down. And to support procedure overloads, sorry, sinuses are driving me nuts. I have to take advantage of the fact that I have a multi-map in the identifier map, and the interface kind of propagated all the way out, right? So on block, we have an identifier map. The identifier map is a multi-map. So when you say find an identifier by name, you could get back a list of identifier pointers, not just one. It used to be you always just got back one. And in the vast majority of cases, for everything in the language, you're probably just going to get back one. But in the case of procedure calls or procedure overloads, you might get back more. So in order to support everything, I had to change the signature of the functors, essentially. Instead of returning back just an element pointer, which is what most of them were doing, they now return back a visitor result T. Visitor result T is this nice little wrapper struct around a boost any, and it has a type. So it's a tagged union, or whatever you want to consider it. Same idea. So we can now return nothing, a type, a module, an identifier, or an identifier list. And so that interface change will go through the scope manager, impacted several places inside there. So the identifier map, now when we do a find, we're using the equal range on the multi-map, and we walk that range and we dump the identifier pointers from the map into our result list, and we return our result list. And I got rid of the blank line. In compiler types, because I was talking about it, I went ahead and put the instruction block pointer on the emit result, not doing anything with it yet, but I will. So then scope manager. So I took this stuff out of scope manager, moved it into the element types header, and then walk parent scopes, find identifier, walk parent elements, walk qualified symbol. Those all changed now because they're these visitor functions, and they've all been reworked to return a visitor result T. So before, the visitor functor was returning back an element pointer. But now we get back this visitor result, so we can check to see if that visitor result is empty. If it is, we keep going. Otherwise, we just return whatever we got. And then if we get to the end, instead of returning null, we just return an empty visitor result, which we can check with the empty method on it. And the same thing is true for walk parent elements. Find type. So I hoisted the result out, right? Because now we have to do a little bit of adjustment depending on what we get back. So the visitor code just changed now to deal with the fact that we're getting back this result object, and then we have to kind of look inside and determine what we're going to put into it. And the logic is the same, it's just the types involved changed. And so then this is kind of a common pattern now, where on the outside we're still returning that pointer type or whatever that used to be the type that everything used here. So now we just have to look inside that result object, and if it is what we're looking for, we pull it out of the any and send the result on its way. So find module changed, same thing. Identifier, so find identifier, this is the big one. So now it returns a list of identifier pointers. And so again, functionally this is identical. It's just that we have to deal with the return value differently because it's now this structure that has some state in it that we have to analyze and pull things out accordingly. And then I had to sin again and use goto to exit out of this because I didn't want to reproduce this switch statement twice. So, yeah. So we get all the way down here. If it's empty, then, or if it's a type we don't support, you get an empty result. Otherwise, if it's a single identifier, which shouldn't actually ever happen, now that just gets added into the result. And then if it's a list, we just return the list because that's what we need anyway. Then in AST Evaluator, there are a handful of spots where we were calling find identifier directly. And so now find identifier returns back a list of identifier pointers. So we just have to check that list. If it's empty, we didn't get anything. Otherwise, we grab the first pointer. Now that's valid for everything except procedure call, which is kind of why we're doing all this. So this one right here, just to keep it the same, you know, as a first step, this just pulls out the first pointer. But what we really should do here is pull this out. We need to refactor procedure call to take a type reference pointer list. Because what we're going to do is loop over this and make a list of type references, identifier references, sorry, and pass that list in, right? So then procedure call, like, okay, here are the possibilities for this named procedure, and we're going to then have to refactor the indexing mechanism in session to take that into account. So then in session, resolve unknown identifiers is calling find identifier. So again, we get back a list, we have to determine, you know, which one we want, and that happens a couple times. So, assembly directive. This was looking up identifiers. That's why this was failing. We were getting these weird label errors because I had bugged my refactoring. But that's good now. So yes, that's a huge step. So then the next step is commit this, and then we'll refactor procedure call to take a list of identifier references instead of just one. And then I think what we need to do is put an interface on procedure call now to do the argument list indexing slash overload resolution. It should do both of those. It's not a Twitch thing. What you see on the left there is called WeChat, and it's been around for quite some time. It's just an IRC client. Okay, and so just for grins, that's a good one. We'll run it out of certs. Okay, yeah, so now find by type is a bit more expensive. And yeah, but most of it is the same. It's memory, really. This is all code that's like this, I think, is probably stuff I just added. And it's not inexpensive, but this is all just freeing elements from the compiler DOM. Let's try. Ironically, the interpreter almost never shows up as being significant. So you see this down here, TC malloc central free list populate. Like this, again, this just comes back to there's a lot of heap overhead right now. So really the way to get around that, if you look, like the compiler, when we're creating a bunch of elements and stuff, the parser usually has a fair amount of activity. So see boost any equal, this is now popping up because check to rate delete. Yeah, because we have that lots of temps. Interesting. Okay. Standard vector allocate 12%. Oops. Helps if I can spell. Okay, procedure call. So this should become compiler, identifier, reference list T. So again, I'm going to kind of adjust the implementation so it behaves the same as it has been, and then once we get all the plumbing and everything in place, we'll make the larger changes for its behavior.
That depends what's on your mind.
I can't discuss it over the phone.
I know that feeling. I want to talk to you too.
I can explain everything.
Where do we go?
Okay, so in procedure call, we're going to now create an identifier reference list T, which is a vector of identifier reference pointers, because there could be now one or many, and we loop over those and we create the identifier reference out of it and place that pointer back in the list. And then in procedure call, we now pass that reference list. That's what it holds on to. And let's see if I missed anything. I don't think so. And that transformation, everything else should work the same. Nothing else should change. Obviously, the overload scenario isn't going to work. Right, so this is where this we should probably push into procedure call. And what do we need here? We don't actually really need to return anything. So we're going to pass in the session. I think that's pretty much it. That's all we need. I don't need anything else. We have everything here. So if not, proc call, resolve overloads. This cannot come in here. Oops. Okay, so now all the details of what is actually going to happen there are inside the procedure call. Because essentially what this is going to need to do is this is going to need to loop over the references and get the procedure type for each one, and then attempt to index it. If the indexing fails, we keep track of it, and if they all fail, then it was ambiguous. Whichever one doesn't fail, that's the one we would call. That'd be the active procedure type for the call. So Okay, so kind of rework the plumbing on this a little bit so it's closer. So what'll happen is these will be set to whichever are the correct type inference. This is maybe a problem. Because at this point, we don't know what the answer is here. We'll know once we've resolved this, but that's happening like way at the end of type check. Yeah, this might. Actually, no, I think that'll be okay. Because we would have, yeah, we would have resolved these, which would have forced another type inference. But okay. 2H Strike asks, how do you set up a cross-platform abstraction layer? Like as an example, on Windows you can set up the icon and the title, but on other platforms you can't. So there's a couple ways you could do it. And it really just depends on the kind of API you want to create. So, and by that I mean the style of API. So as an example, like DirectX on Windows, if you've ever used that, they have this really atrocious, horrible interface where you can essentially query the capabilities of the system. So they have these huge structures that track all the different features you could possibly have, right? Like across all the different GPUs or whatever, sound cards. And you make a call to DirectX and you say, hey, fill in this capability structure for me. Tell me what this system can do. So that's one approach, right? You're building a cross-platform, abstraction layer for window type applications, desktop type applications. You could create a capabilities or capacity type structure, have an interface, in your API where you call it, and then between either if-defing things in and out or actually having code that runs and inspects the system at runtime, you can then properly set flags telling the user, this is, what this system can support. The downside to that approach is that it puts the onus essentially on the consumer of the library. So as an example, you're using the window title, you could have a capability structure that you pass into your library and it says you can't set the window. That means that the person building the application, window title, sorry. That means the person building the application has to have an if statement or something along those lines that says, okay, I can't do this, so don't make this call. Now, you probably would still have the API there. It just would be a no-op, on platforms where it doesn't do anything. So that's one approach. Another approach would be you could have kind of like I don't want to describe this, a service container, service provider type model where you present your API as an interface, but that interface is an interface of services. So you'd have like a Windows service and a logging service and a whatever, right? All the different things that you would want. And then behind the scenes, based again on your build process or the platform that it's running under, it dynamically is going to inject the correct implementations into your service container, and the on Windows, right? Setting the title and the icon does something. On Ubuntu, it logs a message and tells the user this is a no-op, right? From the user's perspective, they're using the same API and it's safe to call things that are null services or non-implemented services. It doesn't damage anything. It just doesn't. Sometimes it doesn't do anything. So that's another way that you can go about doing it. And you can blend the capability model and that like service interface model together. Like your capabilities could be, you could use a dictionary, right? So it's all key value pair. And that way, you can query your state on the same interface, right? You don't have to have a special, you don't have to downcast, or you don't have to deal with knowing what the actual implementation type is. The interface takes care of that. So yeah, I mean, conceptually, those are some of the ways that you could approach that problem. Yeah, I mean, you can error, you can no-op it. I mean, whatever makes the most sense, I guess, is probably what I would do. Yeah. Identify reference. What? Oh. Hey, Outfrost, it's coming along pretty well. Yep, I built that. It's built into the compiler. Okay, so that's the same error we were getting before. That looks okay. That one blew up. Kaboom. I have a feeling procedures that return something are going to be broken. Broken. Yeah. Yep. So one thing we could do, because it's really only an issue. Well, where do I want to put this? Excuse me. Okay, so for procedures that have one instance, here we just pick that front one, get the type for it. That's what we return for procedure type. The infer type, we get the procedure type from that helper, which means we're going to fall in here. Now for the one that will fail is the overloaded procedure, but we'll figure that out. Okay. Because I'm okay if the overloaded procedure fails for now. Okay. Excuse me. Huh? Oh, that's interesting. Uh, line 15. Print. That's the issue. Yeah. Because before we were always getting back a null if it couldn't find it. But with the list, if the list is empty, we would never create a unresolved identifier reference. So here we have to do that explicitly. If we went to look for that procedure, didn't find it, then we have to add an identifier reference that's unresolved so that it can later resolve it. Subtle, subtle, subtle. Excuse me. Now we're getting into code gen. Yay. Yeah, tricky, tricky. Okay. All right, let's review this. So, procedure call. Changed this guy a bit. So, he doesn't take a single identifier reference anymore. He takes a list of identifier reference pointers. I added a new interface, resolve overloads. So this is pushing that argument list indexing stuff down in here, plus more logic that's going to determine which overload is the one we want to execute. An accessor for the references list, and then internally we have to track, okay, this is the procedure type we picked, this is the identifier for that procedure type we picked. And then I hoisted generating the label because it was done in a couple spots. Might as well just do it once. And then references to the procedure type, which it was inferring from the identifier. We're now going to get that in a slightly different way. So everything is going through that field. And then type inference, we call our helper procedure type, which is going to look at these fields that we have. And if we've got a return type, we're going to infer that. Otherwise, we're going to return unknown. This isn't, I don't think this is working. I think this is null. I'll revisit that. And then procedure type, the logic here changes. So now, if our references list only has one reference in it, then that's the one, we get the type for that. Otherwise, we return whatever the value of active procedure type has been set to, which would be in the overload. The owned element, I have to put the reference pointers in there. Then for resolved overload, for now, I just moved the indexing of the arguments to the procedure type, but more logic has to come in here. So if there's more than one argument or more than one reference, so we have overloads, we need to go through and decide which one is the right one. Identifier reference, I overloaded label name because label name for identifier reference should generate the label name for the identifier, which it wasn't doing, so I fixed that. If there isn't an identifier, then we get whatever the default is for the reference, but we'd never use that. The element builder, so now I pass in a reference to identifier reference list, and that gets passed through when we're building the procedure call. And in the code DOM formatter for procedure call, we now have an array of references. So we can, if you have a procedure call, that call theoretically could have multiple types, procedure types that it points at. So you got to show those. Then in the evaluator for procedure call, right? So we make our empty list, we look up our procedure call identifier. If we didn't get anything back, then we need to put one identifier reference in there that's unresolved, right? So passing null here will cause it to be unresolved. And then we have code later on in the session that resolves that, so that's good. Otherwise, we loop through the identifier pointers we got, and we create references for those, and we pass that through. And that was that was it. So all the parts are now in place. I got to revisit the type inference. Again, I think it's not, I think I have to make the unknown type to look at that again. And then, what else? Right, and then the overload selection, which I could probably brute force an initial version of that relatively easily, but then it'll be trying to optimize it so it's not brain dead. All right, I am going to end it there today. I'm very hungry. So I will be streaming Monday and Tuesday. After that, I will not be streaming on a regular schedule until further notice. So, if I stream, it's going to be very hit or miss. But I'll try to have some more concrete ideas by the 1st. So everybody have a good weekend, and I will see you all Monday morning at 5 a.m. See y'all later. Bye.